Hello, I'm Sir Sweya, the member of group number 11. We are presenting a project about simple, smooth, piecewise smooth and the orientation of the curve. Graph or a curve is said to be simple smooth if it is smooth, and it is smooth if it has no corners and has no breaks, and its derivative exists everywhere. Another is has no stationary points, and it doesn't intersect itself. Also, a piecewise smooth curve. It's said to be a piecewise smooth curve if it's continuous as full and it's made up of infinitely many smooth curves and it has no non-zero derivative, means that its derivative is not equal to zero. And lastly, the orientation of a curve. Here we are talking about choosing the direction of motion, whether you choose the direction to be clockwise motion or the direction to be anti-clockwise motion. And the applications are like road design, aircraft flight path, robot arms, and the computer graphics. But we are dealing specifically on the road design. You see that road design, highways are built using smooth cars so that they can turn safely and comfortably.
Now, let us focus on the real life example of designing roads. Many people, they see mathematics as just doing calculations with no use in real life. This is the road structure, which is an example of a simple smooth curve. And the space left is a junction where we will connect the two simple curves and form a piecewise smooth. And this is another road designed as a simple smooth curve, and the white stream beside is a river crossing at the road. As you can see, this is just a road constructed which is smooth. It has no sharp corners and breaks. Means that it is continuous and its derivative is not equal to zero at every point. Now, after we connect to these two simple smooth curves, we get a piecewise smooth, which have a sharp corner at the junction. But remember that it also remains continuous throughout. As you see here, this is the piecewise smooth connected together, the two simple smooth connected. Let us take an observation from this point to see that if it is true a piecewise smooth curve, which in our case we have joined the two simple smooth curves. So it is true that it is a piecewise smooth curve since the junction, which is a sharp corner, the cars are required to reduce the speed so that they can turn safely. This shows that mathematics is real. In real life is applicable. For instance, this piecewise smooth curve constructed by engineers. Now a curve. Consider a curve which starts in its motion from point C moving in a positive direction. When it reaches at the corner, which is in point B, it reduces its speed and then it continues its motion to a point A. Note that the velocity will not be equal to zero, means that it have non-zero derivative. Again, it can change the direction of motion from the point A to point B, and then C. This shows that the orientation of car, it is now in negative direction. And that's how the orientation of a curve is used. But remember that the distance will be the same, but we take it as an opposite direction from the first orientation. Now, from the road structure built by the engineers, let us see mathematically how it looks like. From the structure of the engineers built that road, this is the graph, which so we will see how the simple smooth and the piecewise smooth are located here. This is a simple smooth, as we see from point C to point B. It's a simple smooth, which we can label it as a curve 1. Point B is just a junction, and the point A to B is where the curve 2 is located, which shows that the car was moving in the positive direction. From the graph, the line integral of the curve, the whole curve, which is a piecewise smooth, is equal to the line integral of the curve 1 plus the line integral of curve 2, means that the line integral of the whole curve is equal to the summation of the two line integral. But the line integral of the curve is equal to the line integral of the function of RT times the derivative of the function t with respect to time, which will give us the summation of line integral from point A to point B of the function RT times derivative of the function t with respect to t. plus the line integral from point B to point C of the function of RT times derivative of the function t with respect to t. For different orientation means that anti-clockwise, if the car is moving in a different direction, choosing the different direction, you see that the line integral of the function times b equal to the negative of that function, means that the direction will be opposite. Thank you for listening.